This is Dutchess Community College, MAT 221. This is Mrs. Johnson. This is a brief video giving us the basic rules for exponential functions, finding the derivative of exponential functions. Let's start with e to the x. E to the x is the unique function, that function that has the natural exponential base of e, that it is its own derivative. It is the only function that is its own derivative. So our derivative for e to the x is just itself, e to the x. So e to the x is its own derivative. The formula for any other exponential function a to the x, where a is a rational number, a real rational number, is equal to this rule: the derivative of any exponential function a to the x is equal to itself multiplied by the natural log of its base. So if I had 5 to the x, the derivative would be 5 to the x, natural log of 5. If I had 1/2 to the x, the derivative would be 1/2 to the x times the natural log of 1/2. A very simple rule. Let's try some examples using these rules and rules that we already have developed. If I said to you the function is 2 times 3 to the x plus 5 times e to the x, what would be the derivative? Now here's a example of the constant multiple rule that we talked about in an earlier video. I have a constant multiplied by an exponential function. Remember, the constant multiple rule says I pull that constant out and then I multiply by the derivative of the resulting function. So in this case, I would pull the 2 out and then take the derivative of 3 to the x, which is the rule we just came up with, which is itself times the natural log of its base. This is the sum rule, so I would just bring down the addition sign. And here again, I have the constant multiple rule. I have a constant times the function e to the x. I would pull that 5 out because it's a constant times a function, and then take the derivative of e to the x, which is itself. So the resulting derivative, 2 times 3 to the x natural log of 3 plus 5 e to the x. Again, notice that these functions that have e to the x in them, just by plain old e to the x, is just that same function. Let's try another one. What would be this derivative? Term by term, that 2 get pulled out. I have e to the x, which is just itself, so that would be 2e to the x. This is the subtraction rule, which would be just a subtraction. And this uses the power rule, which would be 2x to the first. Here's another one. Again, term by term, derivative of the first term. This is an exponential function. The rule says it is itself times the natural log of its base. This is using the sum rule, and then the constant multiple rule with the power rule. That ends up being 10x. And then the sum rule, and then the constant rule. A number by itself with no function is equal to 0. So we get 2 to the x, natural log of 2, plus 10x. This one I would rewrite first. I would take the x to the third and bring it up to the numerator and rewrite that first. The first term, 2 to the x, would be again 2 to the x times the natural log of 2. That's the exponential rule. Bringing this up as x to the negative 3, I get 2 times negative 3, which is negative 6, x to the negative 4. And then lastly, be careful here. This first term does not have does not have a variable in it. E is a number, pi is a number. A number raised to a number is just a number, and the derivative of a number by itself, remember, is equal to 0. Here, though, I have an exponent that is a variable, which is an exponential equation, exponential function. The base is pi, so using the rule we just came up with, we would get negative pi to the x times the natural log of pi.